Alright, another problem. If I want to find S sub 1, that is A sub 1. Well, A sub 1 is 1 over. This is 1 more than that. And this is 2 more than that. So if this is 2, that's a 4. Again, the answer here would be times 2, 1 over 4. So the important part is the pattern. That's really what we're going after. That's A sub 1 plus A sub 2. And I notice this is A sub 1. A sub 1 is 1 over 2 minus 1 over 4 plus A sub 2. A sub 2 is, put a 2 there, that's 1 over 3 minus 1, and this is always 2 more. So I notice that's a lot of terms. That's okay. So all over if I look at the common LCD 315, 60. Yep. This is missing a 30. This is missing a 15. This is missing a 20. And this is missing a 6. So that turns out to be all over 60. That is 50. 66 minus 15. 66 minus 15 is 51, if I'm not mistaken. And if I am, again, it's pretty much the work. S sub 3 is really A sub 1 plus A sub 2 plus A sub 3. That is 1 over 2 minus 1/4, first term. Second term, 1 over 3 minus 1/5. Plus third term, 1 over 4 minus 1 over 6. Now here I notice those cancel out. And I'm left with 1/2 plus 1/3 minus 1/5 minus 1/6. There's another pattern I could talk about, but I'm leaving that out for now. So this is 30 is the LCD. 15 plus 10 minus 6 minus 5. All over 30, that is 25 minus 11. 25 minus 11 is 14, or over 15, 7 15s. S sub 4, and again I'm looking for a pattern, is first, second, third, and fourth. The first term is 1 over 2 minus 1 over 4. The second term is 1 over 3 minus 1 over 5. The third term, 1 over 4 minus 1 over 6, and the fourth term 1 over 5 minus 1 over 7. And again, I'm more interested in the pattern than anything. I notice those two cancel out. And I notice those two cancel out. I'm left with 1/2 plus 1/3 minus 1 over 6 minus 1 over 7. The LCD here is 42. 21. 42 divided by 3, that is 14. 42 divided, that's a 7 and that's a 6, and over 42, that will be 35 minus 13. So that's 11 over 21. Now comes the big deal. So this is how I'm seeing this. Since this is 1 more than this, it took the next term for the things to cancel. That seems to be the pattern. So the next term, because that's 1 more. Here, since this is 2 more, it's going to take second term for things to cancel. So things are going to cancel out. Let me give myself a bit of space and talk about what does it mean for A sub n, for S sub n. I keep on saying A sub n. I mean S sub n. S sub n is the first term, 1 over 2 minus 1 over 3, plus 1 over 4, 2 more, right? So I'm going to have to list a few terms to see that pattern. 1 over 3 minus 1/5, 1 over 4 minus 2 more 1 over 6, 1 over 5 minus 1 over 7. So again, I'm going to go for a few more. Normally you go until one term cancels completely. So I notice those cancel out. And those cancel out. Terms didn't cancel out completely. But when those cancel out, now I notice that this term canceled completely. That means out of this sum, I'm going to have, out of the first term, 1/2. Plus 1/3. Now, if only the first two terms canceled out and I need to list 5 terms, then I should list the last 5 terms for me to see the pattern. When you go to 5B, when you take Math 5B, you practice with this a lot more. For now, it's only a couple of problems. So the very last term is literally what you see. Exactly what you see. It is that 1 over n plus 1, that's the last term, minus 1 over n plus 3. The term before, subtract 1, 1 over n, subtract 1, 1 over n plus 2. So the fact that it took 1, 2, 3, 4, 5 of those to clear out, I need the last 5 to see this pattern. 1 less, 1 less, the one before that, and one more, and I should see the pattern. 1 over n minus 3 minus 1 over n minus 1. So notice how this works. I look at those two cancel out. Those two cancel out. And those two cancel out. Which means everything in between is going to cancel out. What's left out of the last two terms? Negative 1. Of course, there's a shortcut to this, but since we want to only see 1 or 2 problems on the homework, there's no point in me going over the shortcut and doing all of that. When you get to 5B, we'll talk about that a lot more in details. As for the rest, find the sum. Well, what's the sum? This is where you start. Throw I equal 1 in, that's 1 cubed, plus you'll keep on going until you substitute 3 in. And you go in order because the domain is natural number, so you start with 1, the next one is 2 cubed, and once you substitute the 3, you're done. So that is 1 plus 8 plus 27. What is that? 936. If I mess up on the addition, that's not an issue. Don't let that throw you off. Just the idea, you know how that works. And here it comes again. This is the tricky part. This is the constant. You start with k equal, if k equal 2, this is 3. K equal 4, 3. Where do you stop? K equal 5. So that is 3 of those, which is a 9. And if you go on the next one, I'm going to start with 1. So that's negative 1 times 2 to the 1 plus 2. Negative 1 squared times 2 squared plus 3. Negative 1 cubed times 2 cubed plus 4. Negative 1 to the 4th times 2 to the 4th. And once you plug in 4, you're done. So that's a negative 2 plus 4 minus 8 plus 16. That is 20 minus 12, which is an 8. 20 minus 10. 20 minus 10, which is a 10. I'm sorry. I'm trying not to add in my head, but I can't help it. There it is. Now, they don't want us to find the sum. They just want us to write without summation notation. Write the sum without summation notation. You start with 3. Throw I equal 3. 3 squared times 1 more than 3 is 4. Plus 4 squared times 4 plus 1. 5 squared times 5 plus 1. 6 squared times 1 more. And 7 squared times 1 more. Again, they're not saying evaluate, so we're not going to evaluate those. We're just going to list them. How about B? B, I'm going to start with I equal 1. So that's going to be, actually, I'm going to put it right here. I'm going to say that's negative 1 y squared. When you put I equal 2, plus 1 times y to the fourth when you put 1 in there, minus 1 times y to that, and if you put 3, 2 times 3 is 6, plus, because when you put, so this is I equal 1, I equal 2, I equal 3, I equal 4. That's going to be negative 1 to the fourth, which is 1, and a 4 in there, that will be an 8, minus the very last term. When you put n, you're going to get y to the 2n, negative 1 to the n, and that would be pretty much it. And here, I start with 2, plug 2 in, 2, and this is 1 more. 1 more than 2 is 3, plus 3, 1 more than 3 is 4, 4, 1 more than 4 is 4, it is 5, and once you plug in 5, you would know that you're done. Again, we're not adding this because it only wants us to list them. They want us to get used to going forward and backward with those. Write the sum using summation notation. This is a bit tricky. In the next section, it's going to be a lot simpler. This is I equal 1. Let's see how that works. 3, 5, 7, A1, A2, A3, A4. So it seems we're thinking to find any term. This is 2 more than that, right? This is 3 more, 4 more, 5 more. Well, another way of thinking of this, if I say this is 3, to find any term, let's see. This is 2 more than this, and this is 2 more than this, and this is 2 more than this. So if I take any term, now I could use recursive. I could say to find any term, take the previous term and add 2 to it. But that doesn't fit what I need. Instead, I'm trying to find a formula. I'm tempted to say, since you add 2 every time, take whatever this number is and add 2 times n, where n equal 1 you add 2, n equal 2 you add, and so on and so forth. And does that work? Well, not quite. So this is what I'm going to do. We're going to derive the arithmetic formula right here. We're going to say, look, a sub 1 is 3. A sub 2 is 5. But we said you added 2, so you took the 3 and you added 2. A sub 3 is 7. We said you added another 2, so you took that 3 and you added another 2 to the 2, which is 4. A sub 4, you took the first and you added to that a 6. So if I really think about it, they all have a 3, right? The general term will always have a 3. Here it seems 2 times 1, this is 2 times 2. This is 2 times 3. So it seems, and this is 2 times 0. There's a 2, because I know it's a 2 because it's right there. Times, if this is 1, this is 0. If this is 2, this is 1. If this is 3, this is 2. If this is 4, this is 3. It seems whatever this is 1 less. Whatever this is, this would be 1 less than that. And that's a general term for a arithmetic sequence. A sub n is 3 plus 2n minus 2. A sub n is 1 plus 2n. So, to find any term on this list, replace n by its position. So, a sub 4, put a 4 in there. 2 times 4 is 8 plus 1 is a 9. There it is. 1 plus 2n. That's very good. But we're not going to use n, we're going to use I. The issue is, where do you stop? How do you know how far to go? And this is really out of the next section. But it's good to derive it here because we're not going to derive it there. If I give you 19, if I give you a term on the list, you take 19, replace a sub n by it, that should tell you if that's on the list or not. Subtract 1 from both sides. Divide by 2. That tells you that's the 9th term. Replace n by 9. 2 times 9 is 18 plus 1 is 19. And there it is. Same deal here, except this one is a bit simpler because you do notice what's happening. This is the series I equal, we start with 1 and we'll see how far we go. Or we could start with, let's see what's changing. 2 and 2, 3 and 3, 4 and 4, 5 and 5. So if I start, they all have a 1 and it's negative raised to the n power because it's alternating. The denominator, it seems to be, if this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4. Well, if this is 1, that's 1 more. This is 2, that's 1 more. This is 3, that's 1 more. So this is 1 more than whatever n is. But we're not going to use n. So here, let me write it. It seems a sub n is one of two things. It is whatever this is 1 more, it seems. And if that's what you did, then you're gonna say, wait a minute, but if I let n equal 3, a sub 3 is negative 1 over 4 plus radical 4. The third term on the list is positive, not negative. Well, easy fix. If that's the case, remember, you're going to replace n by I. So that's going to be to the I plus 1 over I plus 1 plus the square root of I plus 1. And in that case, you're going to run all the way to, remember, this is 1 more. What do you substitute in to get 199? That is fine. That's one way of doing the problem. Another way of doing the problem is for you to say, you know what? Why go about this the hard way? Let's do it the easier way. Why not say this is the sum I equal 1, I equal 2 to 100 of negative 1 to the I over, and instead of I, so this is kind of what you're saying. You're saying, you know what, look, that's a 2, that's a 3, that's a 4, that's a 5, that's 100. Just, where do you put 2 in? N plus square root of n, except you're going to use I instead. Remember that? And does this give me the right sign? So if I start with 2, plug 2 in, the very first term now is not a sub 1 anymore, it's a sub 2. We prefer this answer, of course, but that is acceptable as well. And that's pretty much it for this section.